Now what I want to do is I want to go down and change from it doing simple interest to doing compound interest. Well, again, we're going to insert a formula here that will compute my compound interest at the end of each of the various years. We're going to do it compounded annually. So here we're going to say, tell Excel I want to compute. And as we did before, I want to use a principal of $1,000. And if I want to repeat that formula, let me anchor it. So I'll hit F4. And I want to say that times 1 plus the interest rate. Again, I want to anchor it so it doesn't change. And I want that factor of 1 plus the interest rate, and I want to raise that to an exponent. In Excel, the raise to the exponent is putting what they call a caret, which is simply an up arrow without the down stroke. Okay, and that is at shift 6. If I then put shift 6, it's now going to say raise that previous factor that's in parentheses to some exponent. And at the end of year 1, it would be a 1. Or, as I did before, let's use the cell reference instead of the absolute value. So instead of 1, let's select the cell that contains the 1. I now have a formula that will compute compound interest over a period of time. At the end of year 1, since it's compounded annually, it would have exactly the same value as simple did. But now if I copy that area down, let's say go to 20 years, it will increment, keep the principal the same, keep the interest rate the same, but it will now increment to the cell that is referring to the number of years. And here on the second one was A3, which contains a 2. The third one will be A4, which contains the 3, and so forth throughout. Okay? What we can now do, we chart that as well. So if we select the chart in the header, say insert to the chart section, pick scatter graph. Let's plot it with the lines this time. And there you have compound interest graphed. And as you can see, it's not linear, is it? It now actually starts to curve up. Well, that's exactly the benefit of compound interest, is that over time you are actually earning more interest, or the interest on the interest, over that period of time. Okay? If, for example, you wanted to compare the growth of compound interest and simple interest, I left a column, so I'm going to say I want to put the simple interest formula. Okay, and if you call the simple interest formula was the principal, we want to times 1 plus the interest rate. We want to anchor that times the number of years. And thus we have the simple interest rate, and if we would now copy that down, we see indeed that is now computing the simple interest, right? That would be the accumulated amount for simple and compound. If you wanted to illustrate to your reader that of the benefit of using compound interest, you can select both of those columns along with the header. Say insert chart, scatter graph. Let's use a chart and a line, and it will create a graph that includes both series on it. Stretch that out. It now has the legend on there that says compound interest and simple interest. And here you can see that in the early years there's not a whole lot of difference, but as you move out in time, the compound interest is a better return than you would got for simple. This concludes this video.